The first thing we're going to talk about today is adjacent angles. I need to define adjacent angles because we're going to use it for some of the terms that we're learning about today. But we're not going to get heavy into adjacent angles until tomorrow, okay? So something to look forward to. So let's go ahead and talk about adjacent angles. So adjacent angles are two angles that share a common vertex and side. So I'm going to draw a picture so that you can see what I'm talking about here. So these two angles would be considered adjacent angles. Adjacent just means connected, right next to adjacent, okay? And notice that these two angles, they have a common vertex. They also have a common side. Now, some of the problems that we did yesterday, like the one up here on the board, these two angles right here would be considered adjacent because they have a common vertex and a common side. And these two angles right here would be considered adjacent because they have a common side and a common vertex as well, okay? And this supplementary angle problem right here is also considered adjacent because those are connected. Have a common vertex and a common side. Now, we're going to look next at a special adjacent angles, and they're called a linear pair. Linear pairs are supplementary angles that are also adjacent. So they're like special supplementary angles. Okay, they're the ones that are connected to each other. So a linear pair is two adjacent angles that have non-common sides that form a line. Okay, so you've seen these before, and I'll show you in this picture. This would be considered a linear pair, okay? They're adjacent supplementary angles. And when they talk about the non-common sides, these right here are the non-common sides. And you can see that it makes a straight line. I just wanted to make sure, even though you know how to solve problems like this already, I just wanted to make sure you knew that this could also be called a linear pair, because you will see that on some. You might see it on like iReady, or when the next time you take CASP, okay? So that's a linear pair. Now on to what we're going to focus on today. We'll come back to adjacent angles tomorrow, but today we're going to focus on complementary angles. And if yesterday was a breeze for you, today will also be a breeze for you. Okay. And if for whatever reason you don't get all of this vocabulary down before I turn the page, just let me know and I'll put it back up when I'm done so that you can see it. Okay, so I'm on the back side now, and we're going to talk about complementary angles. So complementary angles are two angles with a sum of 90 degrees. Okay, so two angles with a sum of 90 degrees. Let me show you an example. The first example I'm going to show you is an adjacent set of complementary angles. Adjacent just means that they're attached to each other. They have a common vertex and a common side. And let me name this angle too. So A, B, C, D. Okay. And whenever there's that little square in the corner, you know that angle, that whole angle is 90 degrees, or I should say angle ABD is 90 degrees. So those are complementary angles. They add to 90 degrees. Okay, so I'm going to write the formal statement here. The measure of angle ABC plus the measure of angle CBD is equal to 90 degrees. Now, they don't necessarily have to be adjacent to be complementary. Any angles that add to 90 would be considered complementary. So I can have two random angles. So this is EFG. HJ. Okay, all right. So if the two angles add up to 90 degrees, they're also considered complementary. So this is the measure of angle EFG plus the measure of angle HJK is equal to 90 degrees. Okay. And I know you guys could probably do your practice, and some of you may have already done it already, but I do want to make sure I do just two quick examples in your notes so that when you're studying for your quiz, when it comes up, you can refresh your memory and make sure you know what you're doing. So take out a piece of paper. We're going to do real quick notes, and then I'll give you some time to just get your practice done in class. Okay, so our learning target today is I can solve angle problems involving complementary angles. So just one quick thing to remember about complementary angles, and I know that the definition is on your vocabulary sheet, but I just want to put it here in your notes too. The main point is that all complementary angles add to 90 degrees. If you can remember that, you will be good to go. Let's go ahead and I'm going to give this angle a name too. We'll say that this is 32 degrees. F, G, H, J. Okay, so for this problem, we're going to find the measure of angle HGJ. That's our goal. You guys probably could do this in your head in a split second, but I'm going to write it out formally so we can see what it looks like written out. We have this angle, which is 32 degrees. And then we're going to add the measure of this angle. So the measure of angle HGJ. And this little box here tells us this is 90 degrees, so these are complementary. So the sum of those two angles is 90. You guys don't need to write it out formally. I just wanted you to see it and have it in your notes so that you can see, you can look back at it if you need to. But let's just do the math on this. We're going to subtract 32 from 90, and we're going to find that the measure of angle HGJ is 58 degrees. So this angle right here is 58 degrees. So far, so good? Okay, let's throw a little bit of algebra in there, and then I'll let you have the rest of the time to work. So let's say that this angle right here is x plus 10 degrees, and this angle right here is 28 degrees. So we're going to find the value of x. Okay, so we're going to set up the equation. So this angle is x plus 10, This angle is 28, and altogether we know that this is 90 degrees. So I'm just going to simplify it, unsolve it to find that angle, or find x. I'm going to subtract 38 from both sides, and I am going to get 52 degrees. So if x is 52 degrees, that means that this angle right here, if we add 10, will be 62 degrees. 62 plus 28 is 90, so we know we're good. All right, you guys, I'm going to cut you loose so that you can work on your practice. You should easily be able to finish in the time we have left. So go ahead and get started.